Okay, so we saw that we use factorial when there's an order to our row, if you will. Like, for example, when we were lining up the kids, and you're going to line up all of the kids. So if there had been 30 kids, it would have been 30 factorial. 50 kids would have been 50 factorial, which, by the way, is a very large number. But what if you don't want all the kids, but there's still an order? So a permutation is an ordered arrangement in which our objects are chosen from n distinct different objects and repetition is not allowed. So you can't pick the same person or object twice. The symbol NPR, not National Public Radio, represents the number of permutations of our objects selected from n objects. So you're going to take out of the group of, well, let's say 7 of them, you're going to take 3 of them or something like that. All right. So the way to do that is this god-awful formula, notice all the factorials, or you can make Excel do it. And I have the instructions right there, but it's really quite simple. You go, I want to do 8p3. So I go here and I type equals permute, and it says, okay, how many do you want to choose? I want from 8, I want to choose 3. There we go. There's 336 different combinations. So 336. I'm not entirely certain why I brought up the equation editor for that, but that's okay. Here, I'll copy. Here we go. You know what, and just for the fun of it, I'll just write it out what I did. Permute 8, 3 would be 336. So if you wanted to think about it in terms of, you know, a race or something, if you have 8 kids in your kindergarten class and they're going to run a race, what are the number of ways you could have 3 top finishers, right? First place, second place, third place. That's what you've done here, right? All right, now in an Olympic swimming race, there are 9 finalists. How many ways can the 3 medals be awarded? Okay, well, there's 9 finalists, so what you need is you say, okay, of the 9 people that are going to swim this race, how many different ways can I have the 3 first, second, and third place winners? So it's not just 3 winners. It's not like they're equal. It's that somebody has to be first, somebody has to be second, somebody has to be third. It's sort of like lining up in a line, right? Matter of fact, if you watch those races, that's what they'll put up on the scoreboard when it's all over, right? They'll say, okay, you know, here are the 3 winners and so on. I mean, they do it for anything. I remember watching lots of figure skating and gymnastics, and they'll have first team, second team, third team, and so on. They'll make a list of them. So all I'm interested in is the top 3, first, second, third, gold, silver, bronze. Okay, so that would be permute 9, 3. So let me go back here. Equals permute 9, 3. 504 different combinations. All right, 504 different combinations. So I'll go back here and say 504 different ways for the top 3 finishers. Actually, I should say for gold, silver, bronze, because that's how the Olympic Games work. Okay, that's the permutation. So what's coming next? What if there is no order? What if it's not gold, silver, bronze? What if it's just the top 3 and they're all equivalent to each other? That's something called a combination, which honestly gets used a lot more for probability problems in general. So first thing we need to know is how to find a combination. So it's the same idea as a permutation. You're taking R objects out of a group of N objects. But instead of having order, there is no order. And the way to do that is equals combin. I can't remember what I was doing. Combin 8, 3. So I wanted you to see the difference. 8, 3. Okay, did you catch that? I maybe you didn't. So let me just remind you. This is the permute 8, 3, and down here is the combin for 8, 3. And notice they're not the same. See, when you have an order to it, like somebody comes first, then somebody comes second, then somebody comes third, like a race, there's a lot more different ways that can happen than I just grabbed 3 people. And there's no order. There's no somebody was first, somebody was second. It's just like those 3, they're the top 3. That's it. Right? You're not even differentiating between them. There's a lot fewer ways you can do that, because if you're not going to care who was first, second, and third, then, you know, the same 3 finishers finishing in different orders doesn't make any difference to you. So this is only 56. And I'll type that in here. And I'm done.